Hi, Algebra 2. So I'm just going to do two examples based on today's introduction. If you follow along with the introduction table, it explains in words how to do these problems depending on what number is right here. But I also wanted to do a couple examples for you that I'm actually going to take this video and put it on today's lesson as well as, let's see, Thursday's lesson if you want a little reminder before you take an online quiz. So just to recap really quick, because you guys were doing a really good job with this earlier in the year and when we did some review of it, if you, oops, sorry, I'm getting used to the new tablet. Okay, if you see, hello, something like this, the square root of 20, this is not a perfect square. In other words, there's no two of the exact same number that you can multiply to get to 20. So this is when we, remember, break it down. And you're going to break it down into a factor tree no matter what number's out here. This number is really just telling you how many of a number we need in order for them to come out from under the radical. So when it was a square root, which really I could put a little 2 here, but it's kind of redundant. This is a universally known as meaning take the square root of whatever number's under it. You are probably going to remember as I do this example how you simplify this. Remember 20 breaks down into 4 and 5. And remember, there's going to be many choices of how to break down these numbers, but we try to find ones that help us out. Like this one's great because we have a prime number and we have a perfect square. Even though we have a perfect square, and some of you already know where I'm going with this because you know the square root of 4, I'm still going to break it down all the way just for those that don't remember. So the square root of 4, we know the answer is 2, but let's again show why we know that. So 4 breaks down into 2 and 2. And then 5 is done, but we bring them down for the ride because they're all part of the prime factorization of 20. Sorry, I'm getting used to the tablet. My handwriting is never great. But so we've got 2 2s and a 5. Remember, the only way we can take a number out of here is if we have a pair. And that's because we're talking about a square root. So we have a pair of 2s that we can take out from under the radical, right? So a pair of 2s means I could bring a 2 out, and then that root 5 is still left under the radical. So that would be the square root of 20 simplified in that simplest radical form. So that's stuff you already knew. This is not much different at all. It's now just saying it's the cube root. That's how you say this. So this is the square root, and this is the cube root. In other words, we're going to break this down and find not pairs, not 2 numbers. We need 3 of a number for it to escape the radical. And that's all this, that's just to not overcomplicate things. That's how I want you to think about it. This is just denoting how many of a number you need to take this out. So I'm going to do 2 examples. So I always treat these all differently. So 216, we're going to break it down like any other number. X to the 4th, that means there's just 4 x's multiplied by themselves, and y to the 3rd is just 3 y's multiplied by themselves. So I'm going to deal with 216 first. I'll do this one separately. So 216, again, there's going to be a lot of options. So if you don't want to use 8 and 32, which is what I'm doing, 216 divided by 8 is 32. You don't have to. A lot of them work. And again, it's not as easy to find a trick like it is for square roots because we kind of have an idea of, ooh, I know that that's a perfect square. You're probably not as familiar with perfect cubes, so just break it down as normal. And I'm just going to actually, to make my life easier, I'm going to just carry down these variable terms and deal with those in a little bit, but don't forget to bring them down with you. And don't forget this little 3 goes here to remind us this is not a square root, it's a cube root. So we're looking for triples, 3 of the same number. So 8 becomes 4 and 2 32 becomes 8 and 4. And again, I'm just going to bring these down for the ride for now, because that idea is a little newer for you. Oops. Yep. Okay. Okay, so I know this is taking a while. It's a lot. It's a lot weirder with a tablet. Okay, so 4, we're going to keep going. We're going to keep going until we've got nothing else that we can break down, and then we'll see what we have and work with that. If you want to see if you got the idea, then by all means pause this video and get to your final answer, and then you can fast forward to where I circle an answer. I'll make sure I'll always circle the answer and see how you did. So I'm just breaking down numbers. 4 became 2 and 2. 2 was done, so I just brought that straight down. 8 becomes 4 and 2. 4 becomes 2 and 2. And again, I'm going to hold off on these for now, but don't forget about them. They're very important. So x to the 4th, y to the 3rd. Boop. Okay. And again, all of this is under, oh my gosh. I think, oh no, well, I can't even, hold on. Can I even move this? No, I can't. Great. Well, this is just going to be a funky cube root because my hand slipped. Oh, yeah. Let's just cross everything out. Okay. So sorry about that. Okay, so we're going to keep going. We're keep going. Just give myself more room here. Okay. So 2 is done. We bring it down. Let's get this out of the way. This one, bring it down. So again, the ones that are done, just bring them down. You're done, bring it down. This breaks down into 2 2s. And this guy, bring him down. So you probably see why I underline stuff that's done, because it is very common to forget somebody. That's the other reason I don't do a tree. I know a lot of your teachers may have taught you, and I remember I was taught with just a big factor tree where you keep breaking down stuff on the branches, but then you lose stuff. So I'm not going to do that. Okay, so now I'm going to take these guys down as well. We're going to deal with these very soon. Okay, so now it's all broken down, a whole bunch of 2s. So here's the part where we need to use this. Remember, square root, I'm looking for pairs. Cube root, sorry. Bye-bye. Oh dear. Okay, so cube root, I'm looking for triples. So I'm not looking for just 2 2s, I need 3 2s. 3 of the same number. So there's 1 triple that I can take out. That gives me a 2 out here. Here's another one. 1, 2, 3. Out here. And remember, out front, it's not 22. It's going to be 2 times 2. Okay, so this is not a triple. We're done. That one stops. It's a pair. So let's see what we're left with. So we've got 4, right? 2 times 2 is out front. 4 times the cube root of, you have to multiply what's left over. 2 times 2 is 4. And again, the reason that those 2 stay there is that you can't take these out unless you have 3 of them, yeah? And then now we'll deal with these guys. So x to the 4th is the same thing as x times x times x times x. Y to the 3rd, sorry about my handwriting, is the same as y times y times y. So you're doing the same thing with the variables as you are with numbers. You just have to remind yourself that x raised to the 4th power means x multiplied by itself 4 times. So now I've got these all laid out, and y to the 3rd, y times itself 3 times. And now I'm going to look for triples in my variables. I'll make them a different color. Okay. So for the x's, I'm looking for triples. Oop, there's 3 x's right here. There we go, which means I can bring 1 x out. And let's see if I have any triples in my y's. Yep, there's 3 y's. All of the y's get to leave. Awesome. All right, so let's figure out my final answer now. Okay, so my final answer will be The 4 is still out front. We've got a 4. We were able to take out 1x and 1y, and then and everything else stays under that cube root. So there's still a 4 under here and an x under here. So the final answer is 4xy times the cube root of 4x. I'm trying to find the fun pen. Creative pen. No, not you. Creative pen. Smiley face. Okay, final answer. Boop, 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 boop. Yep, okay. So this video is a little long, so if that's enough of an example, go ahead and try the practice problems, try the homework. I'm going to make one more video for one more example of a different type of root that you're not used to. All right, miss you guys. Have a great day.